on the internet or whatever?
Yep. So these videos will be on YouTube. I'll show you the channel to go to see them. That way when you're absent for baseball or for choir or for whatever, and you miss the notes, you can go on YouTube and watch the video as opposed to just copying notes. Okay?
Just copy what it has on there.
So a rectangle is defined as a parallelogram. Okay, yes, we went over parallelograms.
Rectangle. Wanted to pick me
Do I
up.
need to move you to the back? Okay. So rectangle is a parallelogram, which is what we went over yesterday. In other words, we have opposite sides parallel, except one additional thing. All four angles happen to be right angles. Okay, so a rectangle is a parallelogram with right angles. So all the properties of parallelograms, what were some of the properties of parallelograms? Let's go through them really quick.
There's two parallel lines.
Okay, so opposite sides are parallel. What else about opposite sides?
Opposite angles are congruent.
Opposite angles are congruent. Okay, what about opposite sides?
They're the same length.
They're congruent. Good. Okay, what else? What do the diagonals do?
They're congruent.
They bisect each other, right? So all these properties still apply. Plus, the diagonals, not only do they bisect each other, they're also congruent to each other. Okay? So all four angles measure 90 degrees, and the diagonals are congruent. So using this information and the fact that this is a rectangle, we can actually find all these other angles, only knowing this one is 75 degrees. So let's start off by finding angle 2. Now, if this is 75, right, how will we find angle 2? So 90 minus 75, because that has to be a right angle, and so angle 2 must be 15 degrees. Now, Jasmine, you made an observation about angle 5. What did you notice about angle 5? Okay, so we have, because these lines are still parallel, the top and bottom, we have alternate interior angles, so the measure of angle, let's see here, we got 2, 3, 4, so 5 is the same as this one, so 5 must be 75 degrees. Okay. So far we know these, right? That, and that. Okay. Now, notice because these diagonals are congruent, right, and they bisect each other, this length must be congruent to this. Would you be okay with that? So what kind of triangle is this? This top triangle. What do we call that? It's isosceles because the two sides are congruent. And if two sides are congruent,
That means
the angles are congruent. So angle 3 must be the same as angle 2. Angle 2 is 15. So this must be 15. Okay. Now what about angle 4?
it's the same as angle 5.
So 4 must be the same as 5 because again we've got
Equilateral.
not equilateral,
That's
isosceles. So if 5 was 75, 4 must also be 75. And notice, what is 15 plus 75?
90.
Which is this right angle right here. Isn't that convenient?
Yeah.
Okay.
Yeah.
So what about angle 6?
It would be 15.
So 6 and 5 must add up to 90. Well, we already saw that relationship once, so this must be 15. What about 7? It's isosceles, so 6 and 7 must be the same.
15.
So that's 15. And then 8. Well, 8 and 4 must be the same, or 8 and 5, right? So this must be 75. And now we get to our middle angles, 9, 10, 11, 12. And you saw this yesterday. What do the three angles in a triangle have to add up to?
180.
So if we know that 7 is 15 and 6 is 15, can we figure out 12?
150.
Okay, how do you get 150?
30 minus 180.
Okay, so we know that 12 must be 180 minus 30. Right, so 180 minus 15 minus 15, really? Right? And so we get 150. What other angle do we now know?
11.
How do we know 11? So we have, is that good? Vertical angles, so 11 must be the same. So we've got 150. Okay. Now can we use the same trick to find 9 and 10? So we know 75 and 75, so those add up to
180.
150.
That's 30.
And so this must be
30.
30. And so 10 must be
30.
30. Now, what do these four angles add up to? 30 plus 30 plus 150 plus 150.
360.
360. Notice what happens if we draw all the arcs here. What shape do we get?
Circle.
We get a circle, and a circle has 360 degrees in it. Okay, so it's all done. Okay. Next. It says a rectangle ABCD. So notice again the naming convention is the same as parallelogram. We name it by the vertices going around clockwise. It says DE equals x minus 3, and AE equals 4x minus 6. So what is the value of x? So look at DE, so that would be this segment right here. And AE, that would be this segment. What do we know about DE and AE? Fantastic. So DE equals AE. And so that means x minus 3 must equal 4x minus 6. So to solve this equation, we want to isolate the x, so I'm going to subtract x from both sides. And so we get minus 3 equals, now what does 4x take away x? 3x. And then I'm going to add 6 to both sides. And so we have negative 3 plus 6, which gives us 3, which equals 3x. So we finally divide both sides by 3, and we determine that x is equal to 1. Right? Now, on a side note, and those of you who are really astute paying attention might notice a problem with this answer. So I'm trying to find a problem with this answer. It's absolutely correct algebraically. So we didn't make any algebraic mistakes. What is wrong with this answer?
One of them is going to be negative.
Yeah, so if we plug in 1 right here, we get negative 2. If we plug in 1 right here, we get negative 2. So somehow AE is negative? We can't have a negative leg. So this really isn't a possible answer, which tells you that the person who wrote the problem set it up wrong. Or they were anticipating that, and that you would say, you did it wrong. Right? So keep in mind, usually you can plug back in to check the reasonability. We can make sure that we get the same answer. In this case, this particular problem, it can't be done. Okay? So, flip over on the back. There are some additional problems, and then I've got a second page that will go along with this. That's another 6 or 7 questions on it. So you're working on it right now in class. Okay? What I will do is I'm going to get yesterday's homework, and I'm going to put it up on the my projector so you can check your answers. I'll move it occasionally so you can check your answers from yesterday. So when you get out your work from yesterday, sorry, what? Okay. So when you got your work from yesterday, you can check your answers on occasion. But go ahead and get started on this.